Hello everyone, I hope you all are doing amazing. I am Darshan and our team welcomes you to this channel. In this video, we are going to discuss something we all encounter every day, yet often overlook. That is CAPTCHA. And more specifically, how we can use machine learning to refine CAPTCHA systems and make them more efficient. But first, why is this problem in the first place? Let's explore that. Let's quickly define what CAPTCHA is. So, CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. It is a system designed to differentiate between human users and bots, preventing automated attacks on websites, fraud, and spam. We all have experienced it, didn't we? Deciphering squiggly letters, selecting images with traffic lights, or typing in random text strings before accessing a website. At first glance, CAPTCHA seems like a simple solution to secure websites, but there are three key challenges. First, user frustration. Some CAPTCHAs are hard to read, time consuming, or inaccessible for users with disabilities. The result? A poor user experience that could drive people away from your site. Second, bots becoming smarter. As bots evolve, traditional CAPTCHAs become less effective. Machine learning models can easily bypass them, rendering older systems obsolete. And the third one, the balance between security and accessibility. The more complex a CAPTCHA becomes, the more secure it is. But it also becomes harder for genuine users to solve. This is where machine learning comes into play. Okay, Darshan, we see that there is this problem. Now, what's the solution for it? Well, let's have a look at our alternative that replaces this CAPTCHA system. For this, I would like to hand over to Kushi for demonstrating the implementation.
Thank you, Darshan. I am Kushi Tekwani and I'll be explaining the implementation of how our CAPTCHA system works. Our CAPTCHA interface contains a question and an answer field where user need to input their response. The first question is multiply the following numbers 123 and 256. If we enter an incorrect answer like 56,000, a pop-up window will display. Answer 1 is incorrect. Please try again. However, if we enter the correct answer, which in this case is 56,088, it will proceed to the next question. The second question is what is the color of the clothes you are wearing? For this, we can enter any color. Let's say red. And the answer will be stored in the Excel file. We will then be directed to the next question, which is what shape is this? The answer to this question is triangle. Once we click the finish button, a pop-up window will appear verifying that the data has been stored in the Excel file. Here is the Excel file which provides the information about the answers to all the three questions, the time taken in seconds to answer each question individually, as well as total time taken to solve all three questions. That's all from my side. I would now like to hand over the next part of the implementation to Ayush. Thank you.
Thank you, Kushi. So, hello everyone, I am Ayush, and in this segment, I will explain how the ML part works. The goal here is to detect whether a user is a human or a bot, based on their quiz answers and the time they take to respond. The project isn't fully integrated with our backend yet, so I will show you how it works using two scripts. One for training the model, which is isolationforest.py, and the another is for simulate the real-time detection, which is prediction.py. I am using an algorithm called isolation forest, which is great for finding anomalies like the behavior of bots, which often differs from humans. The first isolation.py handles training the model. Here's what happens. I load the quiz data from the Excel. The questions, answers, and the status are encoded into numbers, since the machine learning models work with the numerical data. Then the data is scaled using the standard scaler to make sure all the features are on a similar scale. We train the isolation forest model to learn the typical patterns of human responses and the time taken. Finally, I save the trained model along with the scalar and encoder so they can be used for making predictions later on. The script prepares the model that will help us to predict in real time, whether someone is a human or a bot. So the script prepares this file, isolation forest model.pkl file. Now onto the second script, prediction.py. This simulates how we can use the trained model in the real time. The script prompts the user for answers and the time taken to respond for three questions. Once the input is collected, the script calculates the total time taken. Just like in training, the input data is scaled, and then model makes a prediction. Is the user or a bot? So let's take an example. Uh, so question 1 was 1, 2, 3 into 4, 5, 6. So its answer was 5, 6, 0, 8, 8. For a human, it takes around on an average of 25 to 30 seconds to calculate this. So let's take 30 seconds. The question was which color t-shirt human was wearing. So let's take yellow. It will take around 7 to 8 seconds. The third was detection of shape. So let's take triangle and it will take around say 10 seconds. So it can predict it is a human. Let's take another example. Uh, for the calculation, which is 1, 2, 3 into 4, 5, 6, a bot will take around 2 to 3 seconds max to max. So 5, 6, 0, 8, 10, and let's say 3 seconds. Yellow, it will take around 5 seconds. Then triangle, it will take around 5 seconds. So you can see that it will predict it is a bot. So this is how the algorithm isolation forest works. So for the conclusion part, I would like to hand over to Utsav for the conclusion part. Thank you.
So let's discuss some of the benefits of our solution. First, our CAPTCHA model can ensure privacy by minimizing the collection of personal data as it relies on user interaction patterns rather than sensitive information for verification. Second, it has reduced drop-off rates as the verification process involves simple, easy to understand questions, thus leading to fewer users getting frustrated and abandoning the verification process in between. It also offers stronger protection against automated bot attacks, thus safeguarding user data and online transactions. Hence, we are offering a universal solution which can be applied in various industries like banking, e commerce, government services, etc. So, to conclude, we chose this problem because we found it challenging as it required an alternate approach for CAPTCHA. Whether it's about securing systems, improving user experiences, or making the web accessible for everyone, developing a machine learning model based solution to refine CAPTCHA will have a lasting impact. That's all for today's video. If you found this interesting, please don't forget to like and subscribe. Drop your thoughts in the comments, like what kind of CAPTCHA do you find the most annoying and how do you think machine learning can make it better. Thanks for watching.